Today is March 2nd, by the way. Those of you who like to date your stuff, March 2nd. We're going to discuss exponential functions. The definition of an exponential function is that it involves an expression b to the x where the base b is a positive number other than 1. Some examples, and these are written in horizontal form. We'll put them in regular notation. These all fit the definition, and let's talk about why. The base has to be a positive number other than 1. So 2 is the base, and it's a positive number other than 1. 3 is a base, and it's a positive number other than 1. 3 halves is a base, and it's a positive number other than 1. 3 halves is like 1.5. 3 is the base. It's not negative 3. 3 is the base alone, and 3 is a positive number other than 1. Granted, you're like, there's a negative out here, but it's not in parentheses. If it was in parentheses, then it would be negative 3 as the base. So let's go to non-examples of exponential functions. These are not examples. 1 is not, or 1 to the x is not exponential. A positive number other than 1. I'm already going to show you what the parent exponential graph for base 2. We can have several bases. We can have 3 as a base, 4 as a base, as long as it's not 1 or 0 or a negative. So this is the parent exponential graph for base 2. I already put the table up there. I put the table up there. I want you to make a note of what the table looks like, and I want you to make a note of what the graph looks like so we can do a sketch. There's this thing called an asymptote. Let me spell that for you so you know what I'm saying. There's this thing called an asymptote. Notice how it slopes down here at the bottom? It slopes getting closer and closer to 0, but it never does. So the asymptote, what we say, is the x-axis. It'll never cross, but it'll get closer and closer to. We got to figure out what's happening from the parent graph, this is the parent graph's table, to this graph. We got to describe it somehow. Let's compare these two functions just by looking at them. The one on the left is the parent graph. The one on the right is this new graph. So just by looking, what's the difference from where we started to where we are at now? How would you describe the way it looks? Let me give you those functions. Those are those two functions. So let's talk about the difference between these two functions. This is the parent graph. This is the one that we saw the table for, the graph for. So what's the difference between the two? And I think we saw the connection of how 1/3, if you take 1/3 times the parent function, we see the table shrinking by 1/3. We see the graphs, y-intercept, being 0, 1/3. Can you figure out the difference between the parent graph, this is the parent's table, to the new table? Okay, so we're multiplying by 3. So now I'm going to show you the graph. The one on the left is the parent graph. The one on the right is the new graph. We note the x-axis is that asymptote where it slopes off to. So is that still the case here? It looks like it would still slope off. And then we note the y-intercept. The y-intercept was 0, 1 in the parent graph. Note the y-intercept in this. You see it. It's at 3. So now let's compare the functions. These are the two functions we were talking about. This was the parent graph, and then that was the new graph where I took 3 times the parent graph. Okay, I'm going to start zooming through. Here we go. What if we had these two tables? Could you figure out quickly what's the difference between the parent's graph table and the new graph? This one's hard. What would you be multiplying by from the parent to the new guy. Multiplying by negative 1/2. Let's see if that meets the other requirements. The other requirement in the graph was, okay, we slope off to the x-axis. Does this one slope off to the x-axis? Full show. And then the y-intercept was 0, -1, but now the y-intercept should change to that factor that we're multiplying, 0, -1/2. And you got to ask yourself, does that y-intercept look like it? Sure it does. And can you take a guess of what the function notation would look like? Function notation, that -1/5 is placed in front. There is a connection, I promise you. We're going to go through this one last time. Look at these tables. Can you figure out what the factor is being multiplied? Can you figure it out? What it's being multiplied by? Yeah, look at the 1. The output 1 times -5 has to get to -5. So then when I look at its graph, that y-intercept should be at that factor, -5. Does it look like that factor would be at -5? Let me tell you this, it will. It will be. I cut off the graph too much. But that factor would be at -5. Notice how it still slopes off to the x-axis. It would still slope off to the x-axis. So can you take a guess of what that function should look like? Notice where the -5 that we multiplied by, and that becomes our y-intercept, is there. Here's where I need you to take notes. Exponential functions of base 2. We're just going to deal with base 2 right now. And we're going to talk about that factor being multiplied by the parent graph. You can also expect the x-axis to be an asymptote for the graph. The domain. We can actually plug in any number into this function. We can plug in any number to this function. But the output. So now I'm going to talk about the range. The outputs are positive if that leading number is positive. The outputs will all be negative if the leading number is negative. Now we're getting into exponential decay. I do want you to make a note of these. This is the parent exponential graph for the base 1/2. It can be seen as two different ways. Function notation could either have a fraction to the exponential power x, or because fractions could be written as a negative exponent, I could see this as 2 to a negative power. So let's note the similarities. Okay, so parent exponential graph for base 1/2 is taking a half to a power, or fractions can be written as the denominator to a negative power. X-axis is still an asymptote, and the y-intercept is still 0, 1. So for decay, y-intercept is still 0, 1. Let's get a general sense of what's the difference between exponential growth versus decay, whether we're talking about the graph or the function notation. Similarities. They both will have y-intercepts at 0a, whatever that a coefficient is. So if I have a function that looks like that, the base is this 1/2. The base is being raised to that exponent. So the a, the leading coefficient, is the number in front of the base. So the y-intercept of this would be 0, 3. X-axis is the asymptote, whether we're growth or decay. That's the only difference. If you notice your base is a fraction, or could be written as a fraction, it should be going in the direction of an L. If it's a growth, base is bigger than 1, it's going to be like a J.